Alright class, this next video is on problem number 8, again on related rate, section 2.7. And if you remember the problem, this is the shadow problem, and it states the following. A street light is mounted, so here are a street light is mounted at the top of a 15-foot pole, so here's the 15-foot pole. And there's a man that's 6 feet tall that walks away from the pole at a speed at 7 feet per second along a straight path. And we'd like to know how fast this tip of the shadow is moving when he's 40 feet away from the pole, excuse me. And so, of course, again, usually when I look at the variables, I look at things that are changing. And I notice that, the man's distance away from the pole, that's changing. So I call that x. So x is the distance of the man from the street light. And then the shadow, that's also changing, and it's also moving a distance away from the pole. Remember, the man starts here, so the shadow's right there, and then little by little the shadow starts moving away. So the distance of the shadow is something that's moving, and so I'm going to let s be the distance of the shadow from the street light. And so notice that here, s minus x, and so let me write that down, s minus x. That's actually going to be the distance of the shadow from the man. Okay, and that's going to be the important part right here. So this s minus x is the one that's going to matter for us a lot. Because what I see here is I see two different triangles. I see the large triangle, where this is 15, the pole, and this is s, which is the distance of the shadow. And then I see a really smaller triangle that looks sort of like this. And here I notice that there is, the distance from the shadow to the man, which is s minus x, and then the height of the man, which is 6. And so now with this, now that I view two triangles in there and I have nice measurements, I know that I can set up some type of equation. And we'll come back to that in a minute. So anyways, going to the rates. Here are the rates. Notice that I have a rate for the walking rate of the man, dx dt. I have a rate for the shadow, since that's changing. And we were given then that the rate of the walking man is 7 feet per second, and the rate of the shadow is what we're trying to find. And now you can see that this picture that I have right here on the top right corner allows me to set up a nice ratio. Again, proportions, just like the problem number 10. I have that this side right here, s minus x, if I divide that by the 6, that is proportional, as if I took this, which is s, I know that looks like a 5, but that's an s, over the 15. And now I have a nice proportion that I can work with, and it turns out that the algebra isn't too bad. 15 times s minus x gives me this side on the left, and then I have 6 times s on the right. I distribute the 15, so I get 15s minus 15x equals 6s. I subtract the 9s the 6s, so 15 minus 6 is 9. I add the 15x to both sides, so I get 9s equals 15x. I solve for s. 15 divided by 9 is 5/3. And now here, once I've got a nice equation, you didn't have to do all this, but I wanted to solve for s. But once you solve for s, you can take the derivative, and you get on the left ds dt. On the right, the constant stays alone, but x depends on time, so the derivative of x is dx dt. And we were given that this rate was 7. And so indeed, 5 times 7 is 35, 35 over 3, and our units are feet per second. So the shadow is moving at a rate of 35/3 feet per second. Notice that this problem isn't terribly difficult. I mean, the calculus and the calculus isn't that bad. I mean, the algebra is really nice. I think the hardest part is just trying to come up with an equation. And of course, the lesson to learn here is the equation depends a lot on the diagram that you draw. So this diagram is going to be critical in any problem that you do. So for the quiz, remember that the diagram is really nice, and to label. And again, what you want to label are the things that are changing. The related rates. Rates is a measurement of change. So you want to have the variables be the things that will be changing. Okay, I hope this helps, and I'll see you soon.